Weekend Bharti with your mentor Avila Sarkar. We have ended the last session on discussing the probability in case there is a event. Okay, so that means if there is a single experiment where our favorable or preferable outcome is being defined, and on the basis of that, if any kind of experiment that result is not definite, but the possible outcomes are fixed, on that what would be our probability. Now we'll take, and this kind of probability comes under your theoretical or classic probability that we have explained. Both are same. Theoretical probability, that means the process of getting any favorable outcome out of the total possible outcome if the number of experiment is 1, that means an event. Now we'll see some example where extending this experiment twice, more than one, that means multiple times, what would be the result then. Now in that case, if I take the example tossing 2 coins at a time, or this can also be read as, or tossing a coin 2 consecutive time, 2 consecutive time. Okay, so either you toss 2 coins once, or tossing a coin twice consecutive, and the cumulative result for both the cases, what would be the probability. Why I kept all this, both the things in OR fashion? Because I know logically these are of same experiment. That means doing an experiment with the 2 coins is give you the same impression as tossing a coin twice. Because the answer, if I say, what would be the answer for first case, tossing 2 coins side by side, there could be possibilities that first coin will give you head, second coin will give you also head. The possibility the first coin will give you head, second coin tail, first coin tail, second coin head, or first coin tail and second coin tail. So these are the only possibilities possible with 2 coins. Let's say this is first coin and this is second coin. So these are the possibilities that could come. Now if I do the experiment in the way second, so tossing first coin will give you what possibility? Tossing first coin twice means you are doing a coin 2 consecutive times. So in the first case, the toss may give you head, and at the same coin, if it is possible to get head or tail, means when you are tossing a coin twice, there could be chance that in the first instance you will get head, second instance you will get also head. Okay, this way you can read. This is first experiment, this is second experiment. In first experiment of the coin, there is a chance of getting head first, and second experiment also getting head, or first experiment head, second experiment tail, first experiment tail, second experiment head, or first experiment tail, second experiment. So the outcome are of similar kind, even though we are doing in a different manner. Taking 2 coins and tossing together, taking 1 coin, tossing twice. Okay, so probable results are same. So in this case, if my favorable is both case head and head, so what would be my probability of that experiment or event, because this is multiple event, the cumulative result will be how much getting head, both case is once only, and your probable outcome is how much, how many, 4, head, 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 tail, tail, head. This is not the same, getting one as a head, getting second tail, or getting first head, second tail, or first time head, second time tail. This is our different to consider. So these are 4 kind of results. So your possible outcome is 4, 1, 2, 3, 4, and your favorable is 1. So this is a case of experimental. And what are the other terms? Empirical. Empirical. So both are same. So this is the kind of second. Now we'll take another example to understand this better. More complicated example. That is the second one, tossing two dice, and in this case it will be DICES, dice, or what is it called? This is only, I think the spelling will be 2 dice, like that. Okay, in the singular number it will be DICE, and the plural number it will be 2 dice, I suppose. Yes, I'm confused in that. It could be dice. You just check yourself. It will be DICS or like that. So tossing 2 dice at a time, or tossing a dice twice. So these are all are same. Now if we do that, so what are the possible results for one tossing of one dice? 1, 2, 3, 4, 5 and 6, and for the cumulative results, the second dice result could also be said with in combination of this is 1, 2, 3, 4. Let me take a little space. 1, 2, 3, 4, 5 and 6. And that way the second result also will come 1, 2, 3, 4, 5 and 6. Why I am writing in this passage? Because you need a cumulative results. One, to get a matrix form, you will get the number of combination possible, because when you will get one, here if it is 1, there is a 1 combination, that the outcome will be here. What would be the outcome? This will be 2. Okay, so this way any combination will get, and the matrix will be such that we will get how many results? All total, this way 6, this way 6, so that means 6 into 6 possible results, because I can get for every row I may get other 6 combination. For every row I will get 6, here also 6, so 6 into 6, 36 possible results. Okay, now my favorable, let's say favorable outcome is when the, let me assume that sum is 8. So I want to get that result only where the tossing of 2 dice together will give you 8, or consecutive result together will give you 8. Okay, so what are the sum? Now as we are talking about the sum, so we'll see what could be the results if different combination comes. Okay, now out of this we'll choose where 8 will come. So let's see, if 1 and 1 comes for both the results, I will get 2 as a result, as a sum. So 1 and 2 comes 3, 4, 5, 6, 7, and the next 3, 4, 5, 6, 7, 8. This 4, 5, 6, 7, 8, 9, and this 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11 and 12. This could be the possible outcome as a sum. Okay, now my interest to get 8 as a result. So where we are getting 8? This one, this one, this one, this one, and this one. Any other date anywhere you are finding? No. So 1, 2, 3, 4, 5. So out of the total, 5 is the result. That is my favorable outcome. So probability, if I want to get the event, where event will it's need to have sum is of 8. So that is number 5, and out of the total 36. So this will be my probability. Now once you do this matrix, out of this matrix you can answer anything needed. Let's say I need 4, so there are 4. I need something where some other things, odd number may come. You can ask for odd numbers, so you just find where the odd numbers is coming, so you can get or even numbers. So many things can be possible once you make this matrix. Okay. Okay, fine. So now we'll start solving examples or some, because there is no much to discuss for this level, because I don't want to go in deeper in such cases. Okay, so we'll solve few problems. Once we'll get acquainted with this subjects more, so we'll try to do some tougher problem together. Okay, so so that where we can reach out to combine with any other subjects that needs this concept probability. Okay, so right now we'll do some simple problems from the books. So let me start first solving problem for you. Now initially I will take the exercise that is being described. Those problems I will put it in example where the learning will be easy, understandable. So example, so we'll see it as number 1 problem. Okay, so okay, I'll take it first one. 1500 families okay, what we are saying, yeah, 1500 families with 2 children were selected randomly. Okay, and the following data were recorded. Okay, what are the number of girls in family, okay, are 2, 1, 0, and number of families are given as 475, 814 and 211. So what I have to calculate, we need to compute the probability of a family chosen at random having 2 girls, 1 girl, and 3 0 girl. Okay. Also, so the sum of these 3 probabilities are 1. So that is the second one. But thing is that where we have to start it by taking now the information given is that 11500 families with 2 children were selected randomly and the following data were recorded. Now this part of the question, what it suggests, what kind of thing we are doing, we have explained theoretical, experimental and axiometric. Now during theoretical, what we have explained, that it will give you a result of a event, and for that you don't need any data to be collected. Okay, that means when you toss a coin, you will definitely get either head or tail. To decide that, you need not to have data in your hand. What are your past experience on tossing a coin? You will have definitely head or tail, and if you want to calculate the probability of a head or tail, it definitely will come half. It does not need any prior data. But when you perform that same experiment several times, and after doing several times, let's say I'm done it for 8 times, on a 9th time, what will come to predict that I need that 8 time data that I did in that circumstances. Okay, so if that is needed, so that comes under experimental probability. So now the data has been collected and tabularized is based on experiment, and on that basis we have to choose what could be the probable results where 2 girl children can be selected, 1 girl children be selected, and no children. Because possibilities of the children, when it is chosen 2 children, not specifically, there could be possible that 1 boy, 1 girl, 2 boy, 0 girl, or 0 boy, 2 girl. These are the possibilities out of the total selection. If I assume that there are only 2 gender, boys and girls, okay, that you have to assume anyhow. Okay, so when the number of families 11500 from which it has been selected, and specifically the families are distributed like that, number of girls 2, when the families are this much, girl 1. So to probability of 2 girl is only in the family where 2 girls is present. If you choose from them only, you will get 2 girls. So probability of getting 2 girls out of 1500, so your total possible outcome is getting 2 children is 1500, because from this is your range. That means what we call it space. Okay, this is sample space 1500. This is sample space from which, so this is possibility of getting 2 children, because every family of 150 having at least 2 children, whether it is girl child or boy child, having 2 children, from where you can pick that. This is already declared, because from 1500 with 2 children being selected. So this family have 2 children definitely. So your possible result is 1500. But your preferable result is what? Getting 2 children. Okay. So now the probability of getting 2 children out of 150 is 475. So this is your possible family, because we are comparing the same family, because at the end this probability doesn't have any unit. Now if we, one thing that is definite, when the unit is family, it must be family. Don't confuse it 2, because you are preferable to getting 2 children, but 2 children out of the family na. So 2 children out of how many families? Where 2 children have girl child is possible, because where it is 1 children, that cannot be a consideration to get 2 children, 2 girl children. So your probable results, where getting 1 girl children, you are having this much of girl children, because the 2 children being picked from each family, not picked from one from this family, one from this family. It has picked from each family 2 children. So getting 2 girl child, this much. Getting 1 girl child, this is the possibility. It's not that one child is taken from this and 1 girl child taken. Then also this possibility of getting 2 children, but it's not like that. For each family, what I said, this families with 2 children were selected. The family itself being selected where 2 children are there, not that the 2 children been taken out. The families are selected where 2 children are there. So how many families? This much. Out of that, how many families have 2 girl children? This. So this is the probability of getting 2 girl children where family is being picked. Where 1 girl children, definitely this will be your result. And where no girl children, 0 girl, this is the possibility. Isn't it? Now you see, adding all these 3, that means adding all the numerators. Now these figures are is the distribution of the this much of family, because this is distributed in a fashion that where we will get 2 children, 2 girl children, 1 girl children, and no girl children. So this is the distribution of this 150. So when you add all these 3, definitely you are adding, keeping the same denominator, adding all the numerators, and definitely these are the addition. This is the distribution of 1500. So that means if we add these 3, definitely you get 1500. So there is no question. The second part of this, which you have to prove, if that P2G plus P1G and plus P0G is equal to 1. So definitely we will get 1, because the numerator, if we add, we will get 1500, and denominator is already having 1500. By cancelling, you will get 1. Okay, so this is obvious one that has to be proved. Okay, so I will end up here with this problem, and the next video I will start from problem number 2. There is no much theory in between. If any concept comes, I will explain then and there with the help of the problem when I will discuss. Okay, so that will be a part of the problem solving, and that will be a part of the analytic part of the probability. This is not meant for as theory, that is meant for some concept that is useful to solve problem only. Okay, you cannot take it as a theory. So if comes there, then and there I will analyze that and I will make the concept clear to you. Okay, so thank you for now. Good night.